Herzlich willkommen zu einer neuen Folge Nebula Mysticum. Mein heutiger Gast ist Dr. Martin Elvis, ein angesehener Astrophysiker am Harvard-Smithsonian Center for Astrophysics. Seit Jahrzehnten erforscht er einige der faszinierendsten Phänomene des Universums, darunter Quasare, schwarze Löcher und die Entstehung von Galaxien. In den letzten Jahren hat er sich intensiv mit der Nutzung von Weltraumressourcen beschäftigt, insbesondere mit dem Asteroidenbergbau und dessen potenzieller Bedeutung für die Zukunft der Menschheit im All. Mit zahlreichen Publikationen und seinem Buch über Asteroiden zählt er zu den führenden Stimmen in diesem Bereich. Dr. Elvis, like I said, thank you for joining me today. I want to start with a few basic questions because I'm always interested in how people started with what they're doing. So, what first inspired you to pursue a career in astrophysics?
Probably reading some books in high school where I had a good physics teacher. One, in fact, I had two. One who was inspiring and fun, and one who actually made me learn the stuff. So, which is a different thing. I got recommended some books to read on relativity and quantum mechanics, and I went, "Whoa, this is amazing! I will never understand this unless I study it for real." But I didn't actually know what research was. One of the professors showed me a paper and I didn't want to do like solid state physics because it was too small. Nothing wrong with the field, it just didn't appeal to me. So I wanted to do something big like astronomy or particle physics. And I had no idea of the difference between the two, really. So one professor showed me a paper written in particle physics, and it had like 100 authors. I thought, oh, hopeless! I'll never stand out in that crowd. Of course, now they have 1,000 authors on those papers or something like that. Then one in astronomy, and there were like 2 authors, maybe 3, and I went, yeah, that's better. I stand a chance there. So that's why I went to do astronomy.
Have you been a big fan of science fiction when you were younger?
Oh yeah. There was a summer when I read my way through the entire shelves of the local library, reading all the usual suspects: Arthur C. Clarke and Isaac Asimov and Heinlein and so on.
Yeah, that's the really good stuff. You've published over 500 papers.
About 500 papers.
Is there a particular discovery or project that you're most proud of?
Oh, well, I was very lucky to be in at the beginning of X-ray astronomy. And so we were able to discover new things then. And my thesis is basically summarized by saying, oh, look, there are lots of X-rays coming from supermassive black holes, which we couldn't know really then, but we called them active galaxies or Cepheid galaxies. There were galaxies where they had a bright nucleus with an enormous amount of power coming out, about equal to the whole of the rest of the galaxy. And they weren't expected to be X-ray sources, and we found that they were, and that had a lot of implications. So that was the first thing. What did I do next? Probably mapping out how that emission from those active galaxies, the supermassive black holes, is emitted across the spectrum. And the good news is that they're very democratic. They spread their power over many, many bands of the electromagnetic spectrum about equally. And that's nice. It's completely different from what stars look like, which have a particular peak in their spectrum, which is where the so-called black body peaks, depending on their temperature. So cooler stars peak at longer wavelengths. And that doesn't apply to quasars. They basically blast out all across the spectrum about equally. And that was surprising. And what's strange is that the mapping out of the whole spectrum like that we made with a very few objects 40 years ago is still pretty accurate. It hasn't changed much. And so that means that there's something very robust about whatever process makes this continuum. Mm-hmm. So we don't really understand that, but we see that there is something simple behind it all.
Yeah, very interesting. What's the most mind-blowing thing you've learned about quasars and black holes?
That they exist. Because it was very much when we first published things that and mentioned black holes, it was a new term, and we were all saying, "Well, it's a candidate. It could be explained with a black hole, but you can't be sure." And now it's obvious. In fact, right? You've seen the Event Horizon Telescope image of the shadow of a black hole in our galaxy and in a nearby galaxy. There's no doubt,
Yeah.
which is just astounding that those things are real, even though they're predicted by Einstein over 100 years ago, 110 years ago. Um,
Yeah. It's
yeah,
fascinating. Yeah.
even Einstein didn't believe they really existed. It was just a formal solution to his equations.
If you had to explain the significance of black holes to a complete beginner, just like
Ah,
me, what would you say?
oh, I'd say they demonstrate one of the things that they demonstrate how weird the real universe is when you get out and look. There are many strange things in the universe, and they're perhaps the most obviously strange. Uh, what's strange, one of the paradoxes of them is that they emit no light, and yet they're needed to make the brightest sources of light in the entire universe. It's the as gas falls down onto them, it's going down a deep gravitational well, and they accelerating very fast. So the material's moving very fast, a good fraction of the speed of light. And when two glass clouds hit each other like that, they shock and get extremely hot and emit like I said, all across the spectrum. And it's not just two clouds; it's many, many clouds, and even a continuous sort of accretion disk. It's called is most likely
Yeah.
what's causing this emission. So two clouds is the easy case, and then it gets complicated because you have to deal with a lot of it. So yeah, that's all technical stuff.
Yeah. You wrote a book and it's called How Love, Fear, and Greed Will Determine Our Future in Space.
And I happen to have a copy here.
Oh, here we go. Yeah.
Yes,
And in this book, you discuss asteroid mining. Do you
yes,
see space resources, let's say, as a game changer for human civilization?
it certainly could be. The resources in space are vast. They are much more in just the main belt asteroids, which are most of the accessible material we could mine. Have of something like 1 million times the resources available in the crust of the Earth. So we could have vastly bigger civilization than we have now. Bigger isn't necessarily better, but it certainly could be.
What do you think are the biggest, let's say, scientific, of course, and ethical challenges for extracting resources from asteroids?
So there's a lot of technical challenges, right? And then there's the economic challenge of making it profitable. And then there are ethical challenges in the sense that should we just mine everything? We could mine, for instance, the rings of Saturn are made of pure ice. And it happens that the amount of water in those rings is just enough to refill Mars's ancient ocean. So we could swap that, right? We could terraform Mars by taking away the rings of Saturn. What do you think of that? Is that terrible? The rings of Saturn don't have any rights. On the other hand, it would be to me a terrible shame if we did something like that. If we destroyed pristine places that, in themselves, some argue have no value, but to me, I think they do. If we just destroyed these in order to build more space cities where everybody lives in a can, is that good? I'm dubious about that. It doesn't mean we won't do it, and it doesn't mean we shouldn't do quite a bit of it. But should we go on until these resources are exhausted? I don't think so.
Yeah. Who owns space?
Yes, nobody owns space, and that's a real
Yeah.
problem. Is it the Outer Space Treaty, 1967? Was all about preventing nuclear bombs in space and stopping either the Soviet Union or the Americans having dominance and like we own the moon and we can throw bombs down onto you kind of attitude. So the principle was laid down that there should be no weapons of mass destruction in space, and that no one could appropriate territory, have sovereignty over any territory in any celestial body, the moon and anything else. So you can't own a piece of the moon, you can't own Mars, but that leads to legal problems, because if there's no body in charge of saying who can mine here and who can mine there, which means it's a free for all, which is not necessarily, which is a way to incentivize quickly grabbing and exploiting all that you can, and using it up as quickly as possible. So that's a bit of a ethical challenge, I think, because it's not a very smart way to proceed.
Right. You're absolutely right. You mentioned terraforming Mars. That's
Yeah.
interesting. To me, this is a
Mhm.
very interesting topic. Do you see that? Do you see that coming?
In a way, I fear it. Mars is a tricky case. First of all, there's a wonderful book, which I don't have here, do I? No, I don't think so. Called The City on Mars by Kelly and Zach Wienersmith. They point out how it's actually a lot more difficult than you think, because there's no, basically you're living in a vacuum, you're living on poisonous soil, and it's mighty cold, and we don't know how if humans can reproduce in 1/3 gravity safely, and who's going to take that experiment, right? That's no one. You can't make someone do that, or try it, and it's a bit. It's I would say it's pretty scary. The other question is, what if there's life on Mars? And Carl Sagan said, if there is life on Mars, in his Cosmos series from many years ago,
Yeah.
he said that if there is life on Mars, even if it's just bacteria or something like at that scale, then Mars is for the Martians. We shouldn't get in the way. If we destroyed that second Genesis, that would be a terrible crime. Effectively, I'd put the word crime in there, but it would be something of a disaster.
Mars is very interesting to me. I've seen some really interesting pictures from Mars.
Oh yeah,
I actually do love the picture of they call it Inca City on Mars.
I don't know.
No, no, they call it Inca City. It's very interesting structure. So, do you think there is a need for us to go mining in space?
Probably yes. That is, there are things which are rare on Earth and which we could benefit from. In the short term, there isn't that much. I have a former student who's working for a company called Interloon, which wants to mine helium-3 from the moon. And that was long ago advertised as a great thing. This happens to be more concentrated on the surface of the moon because it comes from solar wind particles embedding themselves in the top of the soil, or regolith, as we call it,
Yeah.
on the moon. It was advertised as the answer to fusion power on Earth, and so mining it now for fusion reactors that don't exist seems like not a very economic idea. But it turns out helium-3 is now useful in all sorts of applications, including medical applications, security applications for screening for radioactive material, and most intriguingly to me, for quantum computing, to make very, very
Oh,
cold uh, uh, make your electronic quantum chip very cold so that the states last longer. And to get the refrigerator that does that is called a dilution refrigerator, and it uses helium-3. And so so helium-3 is actually worth $20 million a kilogram at the moment. So that's the most expensive material that I know of. Probably that there is.
wow, interesting.
Yeah, so that could be. There's a lot of barriers to, obstacles to overcome before they can actually do it, but they're working on it. So there could be other exotic things that we haven't thought of. There are certainly minerals on asteroids which do not exist on Earth, and mostly that we get them from meteorites. They're not formed on Earth; they come to Earth in meteorites, and we can see them. They're usually tiny flecks. But some of them may have strange, interesting properties for technology. People always talk about rare earth elements. There's a place on the moon called the creep terrain, which is rich in uh, rare earth elements. Whether they're not really very expensive, so whether because it's just difficult to, it's not hard to find them on Earth. It's hard to mine them and separate them. So whether that's useful or not, I don't know, but it's a potential thing. And then there's platinum group metals, which some asteroids are probably very rich in. There's a company called Astroforge who is newly started up and is about to send off their first satellite or probe or whatever we call it to go to an asteroid, a particular asteroid, and they just want to demonstrate they can do that for very little money by space standards, like under $10 million. And so maybe they'll be able to bring back a rich haul of platinum group metals. Platinum and palladium are worth 20. Let me get this right. $20 million a ton, or maybe $50 million a ton. The price changes. So it's a lot less expensive than helium-3, but it's still pretty useful in terms of economics. And economics is not perfect, of course, but it's some kind of guide to what is really worth doing.
Sometimes I'm afraid that space mining could lead to some kind of competition, you know? We had
Yeah,
that
yeah,
we had that with the race for the moon, for example. So if someone starts going space mining, everybody wants to do it, of course. So
yeah.
that could lead to conflicts.
It certainly could. I mean, I pointed this out in a whole bunch of papers, and in the book, because there's no property rights in space. So you can't put a mining claim down on a particular asteroid and say, I have exclusive rights to mine this asteroid or to um, assay this asteroid for the next 5 years and no one else can go there. No such regime exists. Same on the moon. There's nothing to say where people want to mine water in the dark regions of the South Pole. There's nothing to say this crater can be mined by the Europeans, this crater can be mined by the Chinese, this crater can be mined by the US. There's nothing at all. It's a free-for-all. And I think that's a pretty bad idea, and that we need to come to some kind of international agreements on these things. I'm immediately concerned, as an astronomer, immediately concerned about the very few wonderful sites on the moon where we could put telescopes, which are way better. They make today's telescopes look like toys. You know, James Webb, yeah, cute, you know, yeah, that kind of thing. But those places are particularly easily disrupted by other human activities like building bases, landing rockets, and mining for water. So there's some kind of balance has to be struck, and so we're trying to get that discussion going at the United Nations Committee on the Peaceful Uses of Outer Space, which seems to be the forum for this kind of work.
Yeah. An international agreement sounds very romantic, but
I know.
I don't see that coming anytime soon.
Well, you have to persuade everybody that it's in their interests, and I think that's easier to do now before there are actual vested interests where somebody has a base and they're not going to move that, right? Or whatever negotiations you say, because it costs an enormous amount. So it's much easier to do now before anyone actually goes back to the moon. So we're hoping to get some kind of deal, some kind of agreements can emerge. Even then, they're not binding. They're not like a treaty, but it could establish norms of behavior. I may be just overly hopeful, but I think we should try.
Yeah, we should. What emergent technology or, let's say, scientific breakthrough, which might still seem like science fiction today, right, excites you the most when you think about the future of space resource utilization?
I would say we would be really help. It would really be helped if we could have fusion rockets, and there are a couple of ideas for fusion rockets, which is, of course, assuming we can make a fusion reactor. But that seems to be coming along for the first time. I feel moderately optimistic about that. There are a whole lot of startups who are taking a more dynamic approach than the official government intergovernmental approach. That could mean we could move a lot more mass around the solar system. We could go to much more. Right now, the number of asteroids we can reach that are worth $1 billion if you could extract their precious metals is a few dozen, perhaps. There'll be more with Starship, maybe a few hundred. If we had fusion rockets as well, that would be just because it's a more bigger and more powerful rocket. But a fusion rocket could be vastly more powerful, and so that would open up probably thousands of asteroids that could be worth mining. So that would be a big one. If you want to get people moving around the solar system, then probably a nice idea I came across from Eleanor Dongia and her associate in Wisconsin is to build use modern magnets, which are being used for fusion reactors. In fact, superconducting tape, which makes electric fields and magnetic fields that are extremely strong, thousands of times stronger than the Earth's magnetic field. And encase your spaceship with people in the middle, encase it in a ring of these things, and it would deflect the cosmic rays, which are one of the big hazards of traveling in space. They're very likely to give you cancer, which most of us would prefer to avoid.
Yeah, very interesting. Let's go science fiction for a second. I don't want to get too deep into it, but I have to ask a question. Some scientists speculate that black holes could be some kind of portals.
Mm.
What do you think about that idea?
I am not qualified to talk about that kind of general relativity stuff. I only read at a maybe a slightly better, deeper level than you would. What accounts of what they do, those folks do. I was struck by an idea that there's supposed to be there's an idea that there's a planet 9 out there that's kicking Kuiper belt objects into strange elliptical orbits, and it's probably a wandering planet about the mass of the Earth, or a few times the mass of the Earth. On the other hand, no one's found it yet, and so another possibility is that it's a primordial black hole. And the primordial black hole, the mass of the Earth would be about the size of this ornament here, baseball sized to an American, cricket size, ball sized to an English person. I don't know what the equivalent in it for Europe would be, but yeah, something you could hold in your fist, except you wouldn't, because your hand would be completely pulled into the black hole.
Hmm.
If that's out there, and it's out in the far reaches of the solar system where it's fairly safe to play with, we could go out there and experiment with a black hole and see if maybe we could spin it up and maybe it becomes a naked singularity. At that point, maybe there are things we don't know about black holes because there's our physics breaks down at a certain point inside the black hole. Maybe we can never do that and nothing interesting happens, but there could be. It gives us a way of seeing if black holes have stranger properties than we could imagine at the moment.
Yeah. We still have a lot of maybes and could be's, right?
Oh yeah, that relies on many levels of maybe. Yeah, there's the idea that you can have a warp drive, the Alcubierre drive, and that's theoretically possible, but originally took infinite energy, and now they've modified that and just takes absurdly much energy. They modified the calculations to be more careful. So then you could say, well, if we could do that, then maybe we can get the energy from that small black hole, or maybe we can do it from quark matter, or all sorts of oddball things out there. You'd need each one of those to be true, and then you could have a warp drive. So the chances are slender, but they aren't zero.
They aren't zero. That's good to know. Yeah. What is your take on possible extraterrestrial life out there? Intelligent extraterrestrial
Ah,
life. Do you have ideas?
interesting. A little bit. We had this thing where there was a interstellar asteroid, Oumuamua, came by a few
Mm.
years ago, And some people, and it had a strange thing on it. On leaving the solar system, it was accelerating more than made sense. So some thought it must be an alien spaceship with a big sail, a very thin, gossamer thin sail on it to collect sunlight to push it. I did write a paper about, well, what if that were true? A lot of people just laughed, and I thought they were being kind of unfair. We know there is life in the universe because here we are. Hi. So, and we know about solar sails and physics is the same. And so, if they existed, it's not impossible that the answer is that Oumuamua was a alien spaceship. Not impossible. Is it likely? So I wrote a paper saying, well, if it were, how would it get? Was it targeted at us? Was it random? Was it debris from their fast in the intrasolar system transport system that they were using these sails, and they would accelerate something with laser, and then once they got to a planet, jump off and let the sail continue into interstellar space. Then they basically leave junk in interstellar space that we run into. There's all sorts of amusing possibilities, but you can actually narrow down. Some things are very, very unlikely. It's actually unlikely that this solar sail could last for 100,000 years without being destroyed by interstellar dust. Turning it, if it could be made of a thin sheet of diamond, for instance, being a very strong material, but diamond is not the lowest state. Graphite is. So if you hit it and heat it up, if you throw a diamond into a fire, it turns into graphite. And so if you heat up little pieces of this sail, it will gradually crumble into just graphite,
Hmm.
very weak, and just be destroyed. So there's a whole load of problems like that. I think it's fun to take that seriously.
Yeah, it's a very interesting topic. I've talked to Professor Avilop about it.
Yes, he was
Uh,
the person I was talking about, of
oh
course.
yeah, yeah, he wrote an interesting book about it, and we had a chat for the podcast. It was very interesting, and he also told me if we want to look for interstellar artifacts, we should look on Mars and Moon for it, on the surface of
Uh,
Mars and Moon.
yes, that's perfectly reasonable. Yes,
Yeah,
in that they're likely to last a long time there, and be easy to investigate if we do find them. The moon's
yeah.
probably even better because it has no atmosphere, so things just stay for millions of years.
It's a big question. Are we alone out there? Some people say it's stupid to think that we are alone because of the, yeah, vastness of space and how big it
Hmm?
is. And I say sometimes I say, why not? I can wrap my mind around it that we are the only ones. Maybe we are some kind of mistake that happened. Even though everything is very complex here on Earth, right?
Yeah.
But maybe we are some kind of mistake. I don't know.
So I like what Martin Rees said about this. I forget which of his books it was, but that if we spend the next I don't know 100 years looking for extraterrestrial intelligence and find nothing, and we can say no, that there are no planets on which there is life in the atmosphere anywhere near the sun. So we can, if hundreds of them we've been able to look at, and they don't find a single one, then and we see no signals, we have no techno signatures as they're called. We can start saying, we are special. We are perhaps unique in the galaxy, and that would be a very big conclusion. We would make our lives more precious. So I rather like that way of thinking.
Sometimes I think if if you were to get in contact with some other intelligent life out there tomorrow, what would be the biggest challenge?
uh, Not letting them know we're here. Because I was what's that wonderful the three body problem
Yeah,
theory?
Trisolaris trilogy.
Yes, I was pretty struck by the Dark Forest analog that he made, and I was like, yeah, probably advertising our presence before we know what's around us is not a smart move.
Maybe they're still watching us and observing us, and
They might well be, yes.
yeah, they see what's going on here, and they think, no, no, we're not coming.
Oh, there's
No.
a wonderful set of of many ways of answering the Fermi paradox of where are they, right? This is and one of them is no, I don't think so. That's not a nice place. Those folks are not nice.
Yeah, maybe they use. quantum physics to hide from us.
Well, they might be motivated to hide too. Exactly, yes.
Mhm.
Which would be kind of funny if we were all hunkered down on our planets or our little solar systems and trying not to be seen.
Sometimes I'm not sure. I mean, it's science fiction, right? And I don't want to get too deep into it, like I said, but sometimes I'm laying in bed and I'm thinking, man, we are so we are a dangerous species looking at our planet, what's happening here. Should we go to interstellar space? Are we made for conquering interstellar space? I don't know if we should do that.
There's a wonderful science fiction book. Greg, what's his name? Oh, shoot. Anyway, in it, he says conquering the galaxy is what bacteria with spaceships would do. It's a pretty dumb idea, and we should be more smarter than that. I use that quote a lot. I wish I could. I will email you the name so you can include it.
Yeah. Me personally, I would love to see us going to interstellar space and maybe find another intelligent life. But on the other hand, like I said, I think we're a very dangerous species. Maybe we shouldn't do that. But
Oh,
hey,
maybe we have no idea how tiny and non-dangerous we are compared
yeah,
with which is what the three-body problem was about, really. How the aliens are so far ahead of us that they could destroy even our very space-time that we live in. So, who knows?
one last question. What's the biggest unanswered question in astrophysics that keeps you up all night?
Keeping an astronomer up all night is just a normal working day, of course. So, what do I worry about most? Actually, it's whether we can actually keep up our pace of discovery. There's plenty more to be done in every field of astronomy, uh, and the related fields in nowadays of planetology, exoplanetology, where so many different fields come together. It's all going great guns, but I'm afraid that we can't afford a new round of telescopes that are bigger and better by an order of magnitude or more than we have now. We might eke out one of them in 30 years, and we really need a bunch. So what I'm hoping is that we can, and so the whole very dynamic and very wonderful field I've had a career in could just grind to a halt. I think that would be sad because it would be premature. We have by no means found everything in the universe and even less understood it. So I'm hoping that the new rockets, which cut the cost of access to space by a lot, actually happen in the very near future, and that they can carry so much mass and volume of material out to space that we can actually start doing things that, like having a round of much bigger telescopes for much less money, because you can change the way you design missions, and then start doing having real space stations where you can do assembly of yet bigger telescopes. And at some point, these things become appropriate to put on the moon if we have bases on the moon and people there, and we can land many tons of equipment. I was talking about preserving the sites for these telescopes earlier. It could well be that really the next super big generation of telescopes would be well placed on the moon. And so there's a lot of things we could do. I think it all depends on making space cheaper and then thinking about how to exploit that capability for science.
Interesting thoughts. I guess you don't think, ask yourself what was before the Big Bang? No.
I don't. But there are people who do. But it's a very speculative field at the moment.
Yeah. So that was interesting. And thank you so much for taking the time, Dr. Elvis. I had a lot of fun.
Okay, a pleasure.
My pleasure. Thank you.
Thank you.